You've probably heard the term PKI thrown around in meetings or seen it pop up in some docs, but maybe you haven't had a chance to actually work with it. Well, that's what we're doing today. No jargon, no theory lectures, just a real world look at how you'll actually use PKI and how you can start thinking about supporting it as a leader or someone helping drive security. I'll kick things off with a simple, clear rundown of what PKI is, then we'll get hands on so you can see where it shows up in your day to day. And with that, let's get into it. Alright, what is PKI? Well, at a really high level, it's how we make sure things on the internet are secure and trustworthy. It works through digital certificates and keys. Think of it like your system's way of saying, yep, this is real, you can trust it. You've already seen PKI in action every time you visit a site with HTTPS, install software, or connect to a VPN. It's doing its thing behind the scenes. At the core, it's built on certificates, public and private key pairs, and something called a chain of trust. Sometimes, depending on the setup, you'll also run into mutual authentication, where both sides prove who they are. But that's the big picture. It doesn't have to be complicated. Now let's see it in action. Demo 1. Replacing TLS. One of the things you'll very likely do in any real-world environment is replace TLS certificates when they expire. It might sound simple, but it actually highlights an important point I'll come back here to shortly. Usually, you know ahead of time when a certificate needs replacing. To demonstrate this, I've set up a simple demo website with a purposefully expired certificate using Nginx. I know exactly where the certificate and key files live on the server, but to get us thinking critically, let's take a quick look at the configuration to see where those certs are stored. So here we see the path. Let's copy the new files into the right destinations. Restart Nginx. And let's check the site again. All right, the new cert is in, the website sees it, crisis has been avoided. Now, it won't always be a website. I get it, it's a little simple. In this scenario, it was just replacing a file and restarting a service. You'll see similar behavior with other systems too. VPN servers, internal APIs, load balancers, even some database connections. Note that if there's mutual authentication between two services and you only replace one file, you'll cause an outage. The whole point of this is to say sometimes it's just replacing a file and restarting a service, in which case Ansible or Puppet will take really good care of you here. Demo 2. Certificate signing request to install. So next, we're going to install an SSL certificate that we've purchased from a certificate authority. This is great exposure to some of the Windows tooling and the process, especially if you have not done this before. If you want to follow along, IIS is free to try. Just download the server evaluation from Microsoft. We'll open IIS, click on our server, go to Certificates, create a signing request, and here we'll enter our information. Bump the bit key length, and choose a place to output this text. Done. We will be using Namecheap for the scenario. I already created an account, paid for a certificate, and now I am beginning the certificate signing request. Here I put in the domain, and we are going to choose the manual process, which uses the string we created on the Windows server just a moment ago. Now I had to pause here because Namecheap required me to verify my identity before proceeding. Every web service will require you to do some kind of verification. I did it through DNS and decided to skip over this part for the sake of brevity in this demo. Here we can see that the certificate is ready for download. Let's unzip the file. And here we can see several different kinds of files: a CA bundle, a CRT, and a PKCS number 7. So now we can complete the signing request. we're going to have to change a file type here. File types and conversions are another and less interesting conversation for another video. IIS wants a .cer file here. We can get away with just renaming the extension this time. We pick the file we just renamed. Give it a friendly name. And for this scenario, we are going to use web hosting. And there we have it. It's been done. Let's take a quick peek at our certificate. Here you can see it's been issued to our domain, and it's been issued by a certificate authority. You just went through the process of buying a cert and uploading it to a server to show a site visitor that you are who you say you are. When you generate a CSR, your private key stays on the machine, and that's your crown jewel. On Linux, protect that key file. You can use the Digicert tool here to help generate the OpenSSL command and avoid mistakes. Demo 3, Internal Cert Request. In this example, we're requesting a server authentication certificate from our internal certificate authority, or CA, to secure, let's say, RDP connections to this Windows server. We've got two virtual machines running. One is our certificate authority, or CA, and the other is a, let's say, web server in this scenario, and it needs a certificate. The web server is going to request the certificate, and the CA, labeled main, will issue it. Let's start on the web server. We're going to request a new certificate. For this demo, we're going to use a certificate template that's set up for automatic issuance. That means no approval is needed. The server gets the certificate as soon as the request is made. Here, you can see the certificate has already been issued and installed on the web server. If we switch over to the CA, we can confirm that the same certificate now appears under Issued Certificates. This is also where we can revoke a certificate if needed. That might happen if the private key is compromised or if the system is no longer in use. But just know, revoking a certificate is a serious action. Granted, this was a very brief demo that just scratched the surface of what's considered to be a complex and almost artistic part of cybersecurity. Quick reminders: pick the right template. The wrong one might issue just fine, but break later when services try to use it. Secondly, set a renewal reminder. Certs don't send warnings. They just expire and take things down. Demo 4, Code Signing. A wise thing to have set on your server is the restriction of script execution. One of the best ways to protect your infrastructure is to require that only digitally signed scripts are allowed to run. For this demo, I've created a simple Hello World PowerShell script. Right now, you can see that it won't run, because the system doesn't trust it. But now I'm going to sign the script using a valid code signing certificate. And now it runs. If you open the script file, you'll see that the digital signature block has been embedded directly into the script. Quick reminder, always timestamp your signed code. Without it, the signature dies when the cert expires. But with it, your code stays trusted long after. Demo 5, TLS on the wire. First, let's drum up some traffic for our PCAP. I'll visit a few sites, and then we can stop the capture. This is a tool you will very likely use in a variety of situations. A common one might be threat hunting or troubleshooting things like failed HTTPS connections or certificate validation errors. Here we are inspecting TLS traffic captured from a PCAP or a network tap. Let's apply a simple TLS filter. That shows us encrypted traffic. Then we look at the SNI field, which is the domain the client is trying to reach. Now we can dig into the TLS certificate itself. It tells us who the server claims to be, who issued the certificate, and whether it is expired or self-signed. This is the core of PKI using trusted certificates to establish identity over encrypted connections. I wanted to leave you with a few pro tips. 1. Separate your trust zones. Use different CAs for public-facing systems and internal ones. If one gets compromised, you won't take everything down with it. 2. Don't mix cert purposes. A cert should do one job. Using the same one for web, code signing, or VPNs creates messes fast. 3. Know your blast radius. If a cert expires or gets pulled, how many systems break? If it's everything, you have a problem. 4. Plan ahead. Buying and approving certs takes time. Don't let PKI be the reason a project stalls. And 5. Don't forget the chain. Even pros skip intermediate certs. It works locally, but breaks everywhere else. We just scratched the surface, but hopefully you're walking away with a clearer picture of how PKI works and why it matters. Check back soon. I'll be diving into SBOM tools and how they reveal what's in your software.